So today what I'm just going to do is go over the questions on the revision sheet or the practice test. So starting from question 1, the equation of the axis of symmetry for the graph to the right is, so this is a parabola. The axis of symmetry is when we fold this in half, and you can see that that goes through that turning point between 1 and 3, so it's the point where x is 2. So where x equals 2. So that's E. Question 2, compare to the graph of y is x squared, which we know is just a normal parabola. The graph of y equals minus 4x squared is. So what do we know about minus 4 as the coefficient of x squared? The 4 causes the graph to go the minus causes the graph to go upside down, and the 4 makes the graph narrower. So it's narrower and it's been reflected in the x-axis. Question 3. The rule for a parabola with a turning point of 1, 1 and a y-intercept of 0, 2. So we know if it has a turning point of 1, 1, the x. So we're going to end up with y equals x. Now where x is 1, what do we need to make this 0? So we need this to be minus 1, and that's squared, and this y is plus 1. And we just check when x is 0, so that is 0, is y2, 0 minus 1 is minus 1, minus 1 squared is 1, 1 plus 1 is 2, so that makes that true as well. So this is the equation B. Question 4, the equation of the graph on the right is, so we're looking at a turning point here of 3. So if we have x, to make this plus 3, we need to have minus 3 here, if x is plus 3, squared, and just check that that works with the point 0, 9. 0 minus 3 is 0, squared is 9, so that makes that true. So this is the equation. For this equation here, the equation of the graph in the form of x plus a, x plus b, the values of a and b are the coordinates of the turning points respectively. The values of a and b and the coordinates of the turning point. So if we know here that if we make y equals 0, so that's along our x-axis, these two are our intercepts, so minus 1 and 3. So if that's the intercept of minus 1, so that will have to be plus 1, and if this is 3, then this has to be minus 3. And what is the coordinates of turning point? So we know that our turning point is going to be halfway between those. So if we go plus 1 minus minus 3 divided by 2, which is 4 over 2, so our x coordinate is 2. X is 2. So if our x coordinate is 2, our y coordinate, so we're going to have put in our equation 2, x is 2 plus 1 times 2 minus 3. So I've got those from these numbers here. And so that makes y equal to 2 plus 1 is 3, 2 minus 3 is 1, so that's going to be 3, so it's going to be the point 2, minus 3. So that's going to be our plus 1 minus 3 and 2 minus 3 is this point here. Okay, question 6. The x-intercepts of the graph, of this graph, actually we're not going to worry about that one at the moment. We'll leave that. You can do that, but I need more paper. For this equation here, so this we know is an equation of a circle, and it's a circle with the y-intercept, the radius of 3, because that's the square root of 9. So what is the value when x is equal to 2? So we'll substitute 2 into this equation here. So 2 squared plus y squared equals 9. 2 squared is 4. So we just do some algebraic manipulation to get y to be the subject of our formula. Minus 4 from both sides. So y squared is 5, therefore y is the square root of 5. So that's going to be plus and minus. So it's going to be D. And the last one for this page, the intersection point of these two graphs is what? So we'll do the same where we substitute minus 4 into this graph. Minus 4 equals minus 2 to the x. So we need to work out what this squared is, what this thing is here. So 2 to the power of what is 4, so x must be 2, because 2 squared is 4. So we're going to have, when y is minus 4, x is 2. So x is 2, y is minus 4, and that's that. Alright, we'll stop that there and I'll start a new one for the second page.